Hey everybody, I am going to show you today how acids and bases kind of work when they dissolve in water. And we know from what we've talked about in the notes that acids produce H plus ions when they go into water, and they do that by losing the H plus. But bases are a little bit more complicated. Bases can increase the concentration of hydroxide in water by either losing an OH minus itself, or there's a reaction that happens with water. So I kind of want to show you both of those. The thing you need to kind of know to start off with is that water is the root of all of this acid and base stuff. So water we know as H2O, but water, when I think about it more as an H and an OH. And so water, when it kind of sits by itself, goes through a process called auto-ionization. And auto-ionization, what it means is that that chemical breaks apart into its ions by itself. So water, when left to its own devices, will break apart a little bit into H pluses and OH minuses. So naturally on its own, water has a little bit of H plus and a little bit of OH minus in there. And what happens is they cancel each other out and they're neutral. But when we take substances that are acidic or basic, what happens is we bump up either the concentration of H plus in there with an acid or the OH minus. And so there's some interaction happening with the different chemicals and water that I want to show you. Now, there are kind of a couple different ionization processes that we'll talk about for acids and bases, and then hopefully that clears things up a little bit. So acids. There is kind of a simple ionization that happens and a more complicated ionization. Acids operate off the idea that they are going to lose an H plus in solution one way or the other. So the most simple way that we can write the ionization is that HCl, when we put it into water, turns into H plus aqueous and Cl minus aqueous. So I have an H plus ion that goes into my little beaker of water. So if we think about the beaker of water here, all of a sudden I have H plus ions floating around in there and Cl minus ions floating around in there. And the extra H plus ions compared to what water normally has makes this substance an acid. And that's the easiest way to do that. But there is a more complicated reaction that shows the same thing, but just adds a little twist to it. What HCl really does is it interacts with the water that is in the beaker. And an H plus is lost by the acid hydrochloric acid. So HCl is going to lose its H plus and it's going to go to H2O. When that happens, the H plus is gone from the HCl, and so what we have left is Cl minus, and that's exactly the same as the first equation. But instead of it just making the H plus, the water turns into something called H3O plus. And H3O plus is a special compound called the hydronium ion. In chemistry, H plus and the hydronium ion are used interchangeably. So in your mind, you need to keep it straight that H plus and H3O plus are the same. So if I say that I have 1 molar H plus, that is 1 molar H3O plus as well. They are identical. So do not get those things mixed up because they are exactly the same thing. So acids work in two different ways. Bases work in two different ways. And I'm going to back up for a second. When you look at this, you say to yourself, hey, this is not that different, the second equation from the first equation. And you are correct. That is true for acids, but bases are a little bit more complicated. Bases kind of look a little bit different. You will see some bases that have OHs in their formula, and those react one way, and then you're going to see bases that don't have an OH in their formula, but they are still basic, and so we have to kind of go over both of those. The first thing we're going to be talking about is chemicals that have an obvious OH in their formula, like NaOH, CaOH, KOH, any of those. you can see right here in the formula that there is an OH, and it makes sense that that OH, when you break it up and put it into water, is going to increase the OH minus concentration. And so for chemicals that have an obvious OH in their formula, we write the reaction for their ionization as just the ions breaking up. So the Na breaks apart from the OH, and we make Na plus and OH minus. And this OH minus here increases the concentration of the OH in a beaker. So if I would draw this, I would have Na plus ions and OH minus ions floating around. And that hopefully makes a lot of sense. Like, hey, it's just this compound breaking up. But when you look at a compound like NH3, ammonia, and you look at its chemical formula, there's nothing in its formula that tips its hand that it's actually a base. However, it is, and there's a special reaction that happens. When NH3 and water come into contact with each other, they react together, kind of like the second equation for the acid. And instead of the NH3 losing an H like we lost it for the hydrochloric acid, in this case, water is losing the H. So H2O is losing an H plus, and it's going over to the NH3. When that happens, I produce NH4 plus, the H and the plus charge get added on there. But more importantly, now that the hydrogen ion left the water, I am left with OH minus. Even though the ammonia doesn't have an OH in its formula, because of how it reacts with water, it ends up making an OH minus. And so in our beaker, when we initially add the ammonia, after we let it react, it makes NH4 plus and OH minus, and we still have a base there. So those are the kinds of reactions that you guys need to be familiar with. This first reaction for acid and first reaction for base are more of a simple ionization, and then the second reaction for both the acid and the base is a little bit more complicated, but you should hopefully be comfortable with those. We're going to give you a little bit of practice, and then these are what you're going to see on your understanding check. If you have any questions, please ask me or Ms. Dixon in a meet, and we'll get things cleared up.